Well, we're back. This is not going to be really, it is the 48206 part 4, but it's going to be a short video. I'm mainly doing this one to answer a question and about the deal with the tubes. The other thing is, as you notice on the radio, it's running. I've got all the wires disconnected, and the reason why I did that was more or less because to do the full troubleshooting, teaching everything, we need to take voltages. I need to show you how to, doing the voltages, and then I also want to do some playing around with signal tracer and the like, as different techniques of troubleshooting and the proper procedures to do it. Probably still will ask some questions. It'll be more of a what if than an actual introduction of fault. With all the wiring in there, obviously the wire dressing was going to cause a lot of problems, plus the wires were in the way of trying to really show you anything. Besides that, we already got, the radio itself has decided to present a nice little troubleshooting problem, so that may be a very interesting one that may take a little while to figure out. So I'll get to that in a minute. The deal about the tube, one of the viewers asked if I had put a resistor in the filament circuit, which is a great guess, and if I had replaced two tubes in here that were 14 or there were 12 volt tubes with 6 volt tubes, then that definitely would have had to happen. By just switching one, I was allowed not to have to do that, and it boils down to a problem in Ohm's law. Every tube, any tube, when it's fully warmed up, has a hot resistance, and when they're cold, the resistance is totally different. So that's how come when you first turn a radio on, it'll flash up. The dial light may dim down real dim, and if you're watching an amp meter or something, you'll see it really draw, and then it'll start coming back down. If you're using a dim bulb tester, it'll flash real bright and then dim down. And the main reason is because the cold resistance draws a lot of current right off the bat. And then as the tubes heat up, the resistance goes up. Well, in Ohm's law, if you know two variables, then you can find the third one. In this case, I knew what voltage that is required for the radio. From the schematic, it says that these run on 117, and running pretty close to that with the variac. The other thing was, I knew what the tubes were set at, what their normal filament voltage was. Then I could also look up in the tube manual and what current they drew, and from that I could find the hot resistance for each one of the tubes. If I take if you use the standard tubes, all the tubes, no substitute, like I've substituted one tube, the 7A7 for a 14A7, the resistance comes out to be 776 ohms total. If I divide that into the 117 volts, that gives me 150.7 milliamps. These are around 150 milliamp tubes. Now, if I go and figure it up with the new resistance, of the 7A7, which is actually a 300 milliamp tube. So I had to figure its resistance different. It works out to be half the resistance of a 14A7, which is 84 ohms. It turns out to be 42 ohms. That comes out to 734 ohms total, and that's approximately 159 milliamps. Now all I got to do is take 159 milliamps and multiply it times my resistance, hot resistance, and I'll give you what my tube drop will be. Well, it turns out all the tubes will be running just a little bit higher. The 35 volt tube will run at 37, which is perfectly fine for a while. It's not going to hurt it. The 50 volt tube is running at 53 volts. The two 6.3 volt tubes that are in there will be running at 6.7 volts, and the one 12.6 volts is the only one that's actually going to be about a volt high, or for relative terms the highest percentage wise be 13.6 volts. None of these voltages is going to harm the radio. Now I would not want to do this on a daily basis and make this my daily runner radio that I'm going to run maybe 2, 3, 4, 5 hours a day listening to it in the background every day, because it's going to strain those the heaters in there and eventually, you know, shorten their life and take them out. But that's how you get by with it without. Now if I'd switched more than one tube, then this would have thrown off this current even more, increased it even more, and the voltage drop across the entire thing would have been increased on each one of the tubes enough that it would be a concern. But with just one tube you can get by with it for testing purposes. Like I say, it's not something that you want to do all the time, but if you need to test a radio, you don't have that particular tube, you can throw in a different one that's just a little, you know, the lower voltage, and you'll be fine, and it will work. Now I've got the tube on order for this. It'll be here Wednesday, I think, according to the tracking information. So at that point in time I'm going to make another video and we're going to start going through some troubleshooting. I want to get that tube in there so I can get these voltages all where they should be, so that I know that my filaments, the heaters are running where they should be, everything's running all right. Now to give you some what's going on with the radio, we'll see if we can. And we say that's right. But you can hear it. It's got a nice, nasty little distortion in it. And now the interesting thing is, the distortion seems to sound like it's overdriving the tube, the output tube, but it's not. So this distortion seems to be coupled with this IF transformer. I can actually adjust it out some and it helps, but I really think it's probably the first audio tube. Now this tube does check good, but the possibility the triode in there is giving me some troubles. Because when you adjust your IFs, you peak them out. That's what you're doing. You're peaking out the signal throughout. When these are adjusted to peak, and primarily this one, which has got the most change in signal strength, that's when we start having this problem. If I crank this back down, take it a little bit off and stuff, this distortion seems to reduce some. That's not the only problem with the darn radio. The other problem is I've got some bias voltages that don't match in any way, shape of what's on the voltage chart. These guys here where it says 0.7 and negative 0.7 volts, the one for the 14B6 is off. The 50A5, which is the audio output tube, is way off also. And I believe, yeah, the 14A7, or it would be the 7A7 right now, is off. They're all reading almost identical, but they're half a bolt off. I mean, they're already supposed to be 0.7 volts, and they're reading 0.2 volts, or a little over 0.2 volts. So, you're going to have to figure that out too. And what's really bad about it is the fact that every resistor, except for 2, have been replaced, and those 2 have no effect on these biasing. May have to go back and do some double checking on those. The other thing about this IF transformer too is when I look at the chart in here on the IF transformer, yeah, the input IF, I look at the primary and secondary resistances, they're off. And they're off quite a bit. I don't mind if they're off a couple ohms one way or another. That's just meters, it's just different things. But the primary is 15 ohms, what could be a short end. It's supposed to be 27. But the interesting one's the secondary. It's reading 36 and it's supposed to be 27. That's 9 ohms high. And so I've tried different transformers in here, other 455 kilohertz transformers that don't seem to have much effect. It doesn't really seem to change this driver issue, which could very well be the speaker. This speaker is not in the best condition. It was really badly scratchy and dirty, and I got it all cleaned up so it's quiet, but it could be bad. Could have some problems with the voice coil, could have damaged it a little bit. The other thing too is the audio transformer, the only thing I did any type of checks on, I did check the resistances. They were within a reasonable close proximity of what is being called for. There's a possibility that there's some leakage, something going on inside that. I do have other speakers that I can try at the very end. One other last little thing that I'm curious about is the adjustment here that's for the antenna trimmer is only seems to do, I mean, it adjusts and it makes a difference, but you got to bring it almost completely out for it to really have a strong signal. And I don't think that's right, so there could be some dirt issues in there or problems with that. So anyway, on the next video when I get the tube in there, then we're going to start running some voltages. We're going to check these voltages. We're going to try to find out what's going on. We'll probably try using the scope, see if we can get some shots of the signal. We'll use the signal tracer because the signal tracer might locate this. Maybe it's not where I think it is. Maybe it's somewhere else in the circuit. At least with it, I can, listen to its speaker, isolating each stage to find out exactly where this noise could be coming from. So it may take 2 or 3 videos to go through this, but one way or another, we're going to hopefully try to figure out what's wrong with it. No guarantees, but hopefully we will. So until next time, thank you very much for your comments. I probably will still give you some stuff, but this little deal here is a real life problem. So if you got any ideas, post them. We'll try them out, see what happens. And Brett, I'm sorry that I kind of pushed the issue. I was just trying to help you with the 4125, so that means you have to make another video real quick, sooner than you wanted to. I'm sorry about that, but it's part of the fun of these, so it keeps life interesting. So until next time, sometime after Wednesday, thank you for watching, and I appreciate your comments and appreciate your support. Thank you very much.